No. Isn't it something to do with power?
Yes, it's an exponent. A logarithm is an exponent. So when you take a log of something, you're changing it to an exponential. Okay. So when you're multiplying two numbers right here that you're really talking about the logs of them, so you're really talking about the exponents, that's why we're adding the exponents. So we're adding the logarithm. So, you know, very simply put, this is x to the 6th, right? Log base x of that, and there's a lot of exponents here, is 4 plus 2 log base. Okay? But, you know, anyway, the whole idea is that you understand that a logarithm is an exponent. So if you're multiplying numbers that have logarithms, you're really adding the logarithms of those numbers. Okay. Same with division. If you had x to the 4th over x to the 3rd, you would subtract. We've already had to do the exponent thing. We've had to do it with halves. We'd have to do it with 3 halves. Okay? But if you're taking numbers that have logarithms and you're dividing those numbers, then you're really subtracting the logarithms because you're subtracting the powers, which is what a logarithm is. Okay? And this one is probably the most common, but it also is the most weirdest to explain, just for me. Okay, so this p just comes around front as a factor. So let's say we have log base 2 of 4. Okay, does anybody know what that is? I hope most of you do. It's 2. Because 2 to this power equals this number. That's this guy right here, change from log form to exponential form. Okay, so let's say we want to change log base 2 of 4 to be 2 squared. Okay, this 2 could come around front because, and what's the log base 2 of 2? And 1 times 2 is still 2. Okay, so it's a power, and it'll come around front. Okay, now this is so important because it makes sense of something that you hopefully can do. All right, logarithm, natural log of y equals x transforms to y equals e to the x. Remember, the assumed power on a natural logarithm is an e. You are welcome to write it. I will not write it, because it distracts me from really what it is. But if you want it there, then you write it there, because it's implied, okay? And then the other one is if you have a different log base, a, that can be anything, okay? Again, a to the x equals y. So those are 2 things that should be in your long-term memory, hopefully by now, okay? Long term. Good one, Maggie. All right. Okay, so ln is the same as log base a. It's just a very specific e. E is that natural exponential growth that happens, and I do mean natural as far as any kind of growth, decay, any of that. It isn't a p. So we're going to be using E more so, and you'll see why here in a minute, too. Oh, sorry. Okay. We're going to use, if we have a choice to use ln or log, use ln, and you'll see why. Okay, but that's rerun information. Anybody have any questions? Okay, hopefully it's not too far out. Okay, so we got 2 more, and we're done with all the derivatives that you have to memorize. That means you got 24. Okay? You had 16 on the quiz, 16 easy points. Okay? Now, ln of x, the derivative of ln of x is 1 over x. Okay? Now remember, I don't know if anybody's saying, well, how is that? Remember, we'd have to go back to the definition to go there. Do you really want to go there?
No.
Okay. All right. This one is the same except we have a 1 over x, and down at the bottom we have a ln of a. That's the reason if we have a choice to use logarithm any base or base e, we're going to use base e because the derivative is a lot better than using that. Okay? And that ln a is not in the middle, it's down on the bottom with the x multiplied by the x. Yes?
On our solution, it runs like absolute value times.
Well, yeah, that'll come later, yeah. Okay, we'll have to figure that one out later. All right, so log base 4 of x, derivative. Okay, we're just going to use the formula. 1 over x times ln of what? 4. Done. It's very simple. It's just applying a base form log. Yes, Elena. Okay. All right. What's this one? Very simple. 1 over x times ln of 3. Okay. No. I just like it just because it just keeps it a little bit separated for me, but no, you don't have to because it's clear it's multiplied. Okay? All right. Okay. All right. Okay, now this is the one that Abby said, wait, this was on the sheet. The ln of absolute value was on the sheet. All right. So this is, okay, let's look at absolute value of x. That looks like this, right? Okay. All right. So we really have a negative piece of that where x is negative. And we have a piece right here where x is positive. And then we have 0, which doesn't matter. Okay. Now, we know that we can't. What do you know about this? What do we know about this? The ln of a negative number. That does not exist. That's right. Just try it if you don't believe me. Try to get on your calculator, take any log of a negative number, it won't work. It doesn't have to be just ln. Right. And say it again, Maggie. This is called the argument. And the argument has to be greater than 0. Can't even be 0. So that's why we're going to be not differentiable there. Okay. So what's the slope of this side? 1. What's the slope of this side? Okay. But once we take these x's and make them positive so that we can fit, because they have an absolute value, this really is just this, is it not? Because we can't really count. So this is also this for your blue sheet. Okay, because we can't really count the negative side anyway. Yes, so it's just 1 over x. You can go ahead and take that to the bank. All right. Okay. Yeah. And we don't. This really doesn't come up until this absolute value. We're not really going to do any absolute values. We're going to do straight up, numbers. We're going to have compositions, but until we do antiderivatives, which is second semester in Calc 1. So we're good. So if you know ln x equals 1 over x, we're good. Okay, so we're looking for f prime of 5, where f of x equals 2 ln x plus 4. Okay, so we got to start with f prime. All right, so how are we going to do that? Product rule? I don't see a product. I see a constant multiple. All right, so let's just multiply the 2, and then what's the rest of that going to be? Chain. All right, that sounds much more. 2 ln, what's my chain? Okay. You can have Maggie's brain back. Right? Okay. The 2 is a constant multiple. Please don't make that product rule and confuse yourself. You've got too much going on. All right. So constant multiple rule says I'm going to hang on to that 2, and then I'm going to take the derivative of ln u. And Lauren Carter, what did we just learn that the derivative of ln u was? You're not Lauren Carter. But we don't have x, we have u, so it's 1 over. Got it. Okay. And we've known about x minus 4 for a while. Sophia, what's the derivative of x minus 4? 1. Okay. I got to put my u in. I'm going to go ahead and take 2 times 1. So that's where it went. And u is x minus 4. There's my derivative. Now remember, I'm going to plug in x equals 5. Okay? So that equals 2 over 5 minus 4, 2 over 1, which equals 2. Okay? Now remember on your calculator, don't forget about math 8. If you want to check yourself, if you have implicit, explicit, I can't do that. You do math 8. Where am I? Sorry. All right. If you go to the home screen and you do math 8, in terms of x, 2 ln x minus 4, watch your parentheses, okay? And in 5, there's your 2. Remember that garbage is exactly that, it's garbage. So 2.000 is 2. Okay, so that's just a check. But don't forget about that piece when you're like, wait, I don't know about that. Is that right? Done. Okay? Any questions about the process? All right. Let's see. Let's talk about the derivative. D dx is the derivative of ln sine of x. All right, Paige, how do I want to work that one? ln would be ln of u. ln of u, where u equals. All right. Good job. All right, Lizzie, what's the derivative of ln of u? Okay, and Maggie, what's the derivative of sine of x? All right, we replace our cosine of x, or u with sine of x. What's a better way to write that? Trigonometry, cotangent. Okay, good job. So smart. All right, very good. So we're just using the 2 new log ones with chain rule, explicit, all that. Okay. All right, f of x equals log base 10. All right, so where do we start with this one, Lydia? Log base 10 of u. Okay. Now remember, this might be written like this because the 10 is implied. If there's no log, it's a base 10 implied. So be careful about that. Because it won't matter until you get to f prime. Okay, so what does f prime of log base 10 of u look like, Ashley? That's over there. 1 over u times ln of 10. Good. Okay. That's the log. It's ln of 10. It's not log of 10, but good question. Way to be thinking there, Lydia. Okay. And what's the derivative of 2 plus sine of x? Holy Sean? Cosine of x. Okay, I'm going to just make that into one fraction. So cosine of x is on the top. And u gets replaced with 2 plus sine of x times ln of 10. There's nothing really I can do with that. I'm done. I could put the ln of 10 out front. You know, you could write it like this. But I don't know. No, you would do it. You leave it on the bottom. Not on the top. Don't move it to the top. Okay. We're looking for the derivative of the ln of this mess. Okay. It says to use the log rules first. Okay. So this is my function. All right. This is division. Okay. Now I would have to use ln of, if I didn't follow my hint, which is always a bad idea, you'd have a quotient rule and a composite rule over here, right? Okay, so that's your alternative, but let's think about what happens. Okay, first of all, when we're dividing the logarithms, what are we doing with their individual logarithms? Subtracting, so that's where I'm going to start. Okay, because I'm dividing, I'm going to subtract the individual logarithms. Then, do I have a power here? Yeah. What power do I have? 1/2. So this is really x minus 2 to the 1/2. We've been doing that for a while since we learned about that. And then what happens to that power? It becomes to the front of that particular thing. Okay, so that's still your function, but that's going to be a lot easier than this mess right here. Okay, to differentiate. So here we go. We're ready to differentiate. I'm going to change pen. I don't know. Thank you, Lauren. All right, that's a minus. Anything else we did?
But is it not ln of x minus 2?
Right. So we took the x minus 2, the power moved out to the front. No, that doesn't have anything to do with this power.
I'm thinking of it.
Okay? No, you're good. Anybody else have questions about, those are your log rules from pre-calc. Those are not anything that, you know, now if you need to refresh those, then we need to refresh them, but they're there. All right, so how are we going to take the derivative of an ln of x plus 1? We're going to do ln of u equals x plus 1. Differentiate, what's the derivative of ln of u? And the derivative of x plus 1? Okay, so that's nice. That's just 1 over x plus 1. Okay. Minus 1/2 is a constant multiple rule. I'm just going to hold on to that. And then I'm going to go and do another u substitution. I'll call it v this time, just not to be confused. 1 over v times 1. So, right? 1 over x minus 2. So what is that? Not too bad a mess. 1 over x plus 1 minus 1 over 2x minus 2. You can get a common denominator, but really it's okay. Yeah, it's all good. Okay, but that's a lot easier than having the division rule, and then within the division rule you have your composite chain rule. So yeah, if you did a common denominator, it would look like, let's see, oops, 2x minus 2. We need to multiply. So it would look like 2x minus 4 minus 1 over 2x minus 2x plus 1. Oops, nope. Yada, 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 yada. Okay. Is it? Get ready for time to go? Okay. We'll wait for us to call on them. All right. We can, hopefully we'll have time to do this when we get back from church service? Or is it church? Church, sorry. You should know that. If we don't, then I'm just going to take these last 3 problems off. Because this is log diff right here. That's the direction. So we will, we'll see if we need to do that next time or not. Oh, let me get the recorder off.